Alright, so there are two desserts that I am absolutely passionate about, and until just recently, I had not been able to eat in a long time. Here's one. Hot brownie. I mean, right out of the pan with a dollop of vanilla ice cream. Oh my gosh. Or apple pie. A dessert? Apple pie with a dollop of ice cream. Vanilla ice cream. Oh my gosh. Okay, especially somebody in my church, actually Jesse, he's a senior here. His mom makes these incredible apple pies. Holy cow. They're fantastic. Best apple pie I've ever had. And we only ate 3 slices last time. We can have it again. Okay, why have I not been able to eat it in a long time? Because I have become lactose intolerant. And so the ice cream makes me distressed. Makes me uncomfortable. Okay, so for the longest time I've been able to only eat apple pie or brownie just without. But several weeks ago, my wife bought coconut milk. Yes. Okay, does it taste like milk? No. Is it milkish? Yes. We put it in a steel container along with vanilla and sugar. Sealed up the steel container, put it in this tub where we put ice, and then a layer of salt, and then a layer of ice, and then a layer of salt, and a layer of ice. And we turned it on, and this paddle inside the steel thing started moving, and then slowly it started slowing down until finally it was moving very slowly. That told us it was done. Okay, so the coconut milk ice cream is not the greatest, but put a dollop of it on apple pie and a brownie. I had that last night. So good. It's so good. Okay, why do you have to add salt to the ice? No. That's what we're going to experiment with today. That's what we're going to learn. I can explain what are colligative properties, and I can explain the concepts of freezing point depression and boiling point elevation, and be able to answer conceptual questions about them. What are colligative properties? Physical properties of a solvent, like boiling point, like vapor pressure, like freezing point, that can be changed by changing the concentration of the solvent that is used. These are physical properties that can be changed by adding impurities. So in the case of my ice cream, I added impurities to the ice, and that changed the freezing. That changed the freezing. How is the boiling point of the solvent affected? Okay, so we've got some false layers here. You work offense or defense, Ryan? You don't? You're offense. You're quarterback, right? What if the game started, you guys lined up, and the defense of the other team refused to take the field? It would be awesome. How successful would you guys be? Okay, so you would virtually score every play, unless of course you threw the ball and it threw fork, right? Okay, so what if we got 2 defenders up there? How successful would you be? Still good. Not as good as if there was none. What if we had 5 defenders out there? Still good? You like that? You'll take that. 11 on 5? Okay. How about 7? You'll take that? 9? Your 11 versus their 20. Wow, you're a brash young quarterback. How is boiling point affected? It's rate. Why do you have to get water hotter in order to boil if you have defenders in there? Because they will quite simply absorb some of the energy that should have been going to you, so that now it's going to them. So now you're going to have to add even more energy in order to get the same result. So, maybe you like cooking noodles. So you get a pot of water. What do you add to the water? Why do you add salt? There's plenty of salt in the sauce. No. Once you boil the noodles, then you add the sauce to it, and there's plenty of salt in the sauce. It does cook fast. It cooks faster because it cooks at a higher temperature. Since you're cooking at a higher temperature, you can cook it faster. So your great-grandma was probably a chemist, and she understood the concept that by adding salt, you were increasing the boiling point temperature, so you would cook it faster. But she didn't tell your grandmother, so your grandmother just adds the salt because your great-grandmother did, and your mother adds the salt because her mother did, and now you think that's just because we want to salt the noodles. No, you want to decrease the cooking. How about freezing point? How will it affect freezing point? It raises the freezing point. What does it do? It raises the boiling point. What does it do to the freezing point? Yeah. Okay, so before a storm, a snowstorm, or an ice storm, what do they do to the road? Okay, it's brine, yeah. Actually, sometimes they even use heat. Okay, why? Because that initial snow that falls invariably is going to melt. Usually the ground is a few degrees warmer than the ambient temperature. So that few flakes that fall will melt and will dissolve the salt. With the salt in the water now, there is no way that it'll freeze. You're going to have to go much colder than here. So, this only works in East Tennessee, in the South, maybe the Midwest. Up north, it only works in the fall and in the spring because it only works if you're hovering around freezing point. If you're going to be much colder than freezing point, it's not going to work. Because all that it's going to do is make it so that the water no longer freezes at 32, it freezes below 30. Up north, when a normal winter you could go below 32, it doesn't help. Because they don't even bother with salt. They would only bother with salt in the fall and the spring when they could wobble in and out of freezing. For us, did it help us? No, we were a solid week under 32. So they grind it because that's what we do here in East Tennessee. If they knew that we were going to be a solid week under, probably not even bother. They just basically wasted a lot of salt. Yeah. Oh yes, it does. It does. It would be, you'd be surprised at how many times they're able to get through a storm on the blind because of East Tennessee. East Tennessee covered. Oh no, why is the freezing point depressed? Because the impurities are going to interfere with the way that the solvent creates intermolecular bonds. So those hydrogen bonds that water wants to form, the salt molecules, ions, are going to get in between them and interfere with the way they work. Why are salt added to the fruit before a big snowfall? In hopes that we can melt that first little bit. That first little bit melts. It'll stay a liquid. It won't freeze. that will interfere with the way that the snow falls and lands on the concrete. If you keep the road fairly clear, then we're okay. We don't care about it. So, here we go. Notice the temperature is 100.5. Why is it 100.5 and not 100? Probably because the thermometer is not. Add salt. And now, 100.6, 8, 9, 101. Add even more salt. Okay, 102. What will it do to freezing point? Yes, Simon, you have a question? It depends. Well, at some point you become a saturated solution and it won't help you. Depends on how much water you have. Depends on how much salt you have. Okay, so here you are at negative 0.4, 6, add salt. We had a student a few years ago that got frostbite in AP chemistry because when Eddie wasn't seen, he did the ice and salt challenge. It was negative 12. His father was a chemist and thought it was really funny. People add salt to the ice and then stick their finger in there to see how long they can hold it. Look at that, negative 2.5. No. Okay, so what's going to happen next Friday? Next Friday, after the EOC, we're going to celebrate by doing a freezing point depression lab. Okay, we're going to take a baggie, sandwich-sized bag. We're going to add heavy whipping cream, which is basically very thick milk. Sugar and vanilla. Now keep in mind that even whipping cream is still mostly what? Water. It's still mostly water. All the cream stuff and the sugar stuff and the vanilla stuff is basically the impurity. If water freezes at 0, at what temperature will it freeze if there's milk stuff and sugar and vanilla? It needs to freeze, it needs to go to around negative 6 degrees, negative 6 to negative 8. Okay? So, if we place it in an environment full of icy water, will it freeze? Because what is the temperature that the icy water goes? 0. Okay? So, it's not going to work. We need to make this environment at least around negative 8, negative 10. So what do? We're going to add salt. By adding salt, you lower the freezing point down to negative 10. Now can the ice cream freeze? And that's what we're going to do. Yes. No. Simon asked that. I mean, there comes a point where you have a saturated solution. It's got to be dissolved in there. No, I think there's some limit. All right, so this is the kind of question you're going to find on the test. Order these things from the one that's going to lower the freezing point the least to the one that's going to lower it the most. And here's your clue. Let's talk about ICBM. Intercontinental ballistic missile. Why are we talking about that? Because they will give us an interesting concept that's important. So the rocket launcher goes into space. In space, it will actually come apart and release individual warheads. One of those warheads can take out a city. So with one rocket, you can take out 5 or 6 tubes. Okay? One rocket gives you multiple warheads. Understand? Okay. Which one do you think is going to lower it the least? Simon? The least. NaCl? Let's think about NaCl. Ionic or covalent? Ionic? Okay, ionic means that when it does dissolve, it dissolves into individual ions. How many ICBMs can we get from NaCl? 2. That's right. So we can get 2 impurities. Na plus and Cl minus. So we get 2 for the price of 1. That's pretty good. That will lower it. That's why we use NaCl, because it gives us 2 for the price of 1. But that won't do it for these. Yeah. Gasoline. Gasoline is CH8. It evaporates very quickly. That ought to tell me right there that this thing is probably weakly held together, which means it's probably polar or non-polar. Non-polar. And it's probably held together by London dispersion forces. Okay. Will it even dissolve in water at all? So this is basically a missile that would contain no warhead at all. This cannot interfere with water because it can't dissolve in water. Folks, we have found the leak. Who's next? Who's next, please? Let's look at MgCl2. Ionic or covalent? MgCl2, ionic or covalent? Okay, metal, non-metal, or non-metal, non-metal? It's metal, non-metal, so it's ionic. That means it comes apart into individual ions. Yes, very good. So this will give you how many warheads? 3 for the price of 1. Yes. It doesn't. If the molecule does not come apart, then it doesn't. Sugar is a good example. C6H12O6. Here's a non-metal, non-metal, non-metal. So it doesn't come apart, but it will dissolve in water because it has a bunch of OHs in it, as we saw before. So it will dissolve, so it will interfere, but how many warheads do we have here? Just one. It'll just fall apart into small until you get the smallest piece of C6H12O6. Yes, if it was ionic, then you would get the winner because it would be 18 plus 6 more, 24. But it's not. It doesn't come apart like ionic. All right, so who is going to affect water the most? Then, and who will not affect water at all?